Let's do the first exercise in which we're going to do parallel plates. So I've put my this special graph paper. It allows us, it has a certain resistivity to it. It's carbon impregnated. So it allows us to map out the electric field. It has just enough connectivity to allow small currents to be able to propagate through the paper. And if you notice, it has lines on it, and these are centimeter lines. What we're going to do is when we map it out on here, we're going to transfer it over to this graph paper, which I provided in your lab. So your lab handout, the lab in the Word, has this at the very end of the particular lab file. You can print it out. Or if you have a mouse, you can actually put little dots on it using, if you want to. That's kind of like, it'll take you a little longer to do it that way, but hey, you can also, if you have a touch screen, you can draw on it. So I've put two metallicized thumbtacks, and I pushed them down really hard so they make electrical contact. And notice that they're on the outside, they're not on the inside. We want to look at the parallel plate capacitors. We want to see if the electric field lines are parallel to these two plates. I'm sorry, the equipotentials are parallel. The electric field lines actually will go from the positive to the negative. What I'm going to do is put the positive here, the 15 volts here, and I'm going to attach 0 volts here. So I've already set my voltmeter to 15 volts. What I'm going to do is take the red, which is the positive, and stick it on here. I don't want to put it on the paper itself. That particular one doesn't have a cover. This one has a little cover on it, so it should be okay, but stick it like that. So now what I've done is I've put electric fields throughout this paper. What we have to do is measure electric field. So to do that, we have a multimeter. So let's talk about the multimeter for a little bit. First, let's talk about what these things are right here. You have the off button, of course, and when you move it up, this little notch goes to V, and the little squiggle line. There's also this yellow thing right here. So the white is what it's going to read off as you move the dial around. If you want it to read the red, the yellow, orange, however it comes out on your computer. It actually looks more orangey. That's hertz. That's measuring frequency. So you press the yellow button, and then it'll read hertz. Now you can see up here it says VAC. That's because this is V, alternating current. If I move this up to V with a steady line on it, you see it's VDC. Then this is in millivolts. So this is reading off 0.001 volts. So this is, it's reading around 0. And that's millivolts DC. And then you have ohms, that reads resistance. It reads 0 right now. I mean, it reads overload because there's nothing on there. This right here just shows you if you have a short circuit. I've put two things, patch cords onto here. I've got voltage. I want to measure the voltage, so I've got the voltage. And if you want to measure ohms or the continuity, you put it on here. And this is the COM. So right now I have it on this thing that looks like a sound, and that's to measure continuity. So if I actually short it out, and I put the red, this is the red, and I stick it back onto the black, you can hear the sound. That means that there's a closed circuit, that there's a continual current. Right now, it's an open circuit. Then this is milliamps. It defaults to milliamps AC. If you want DC, you have to press the yellow button and you get milliamps DC. And the same thing for amps. Again, the amps, you're going to have to use these two buttons. They're completely different circuits to measure voltage and amps. So if you want to measure amps, you put the red in here and the ground here. If you want to measure milliamps, you put your red in here and your ground in there. So what we want to do is measure VDC, so I'm going to set it like this. Then I'm going to put my black lead on this right here, so, and the other one is going to be my probe. So I'm just going to move it around so you can see it a little bit better, see where I'm pointing. And I'm not going to do the entire area, I'm going to do this area right here. I'm going to take my probe and move it around. Now, let's see if we can see the reading and the multimeter at the same time. I'm going to try and put it somehow. I just may have to just keep moving it upward because I may not be able to put it all. Oh, maybe. Let's see. Put it. Okay, so here's our DC. What we're going to do first is check out to make sure everything is working. So I know it looks like a lot of wires. I'm going to try and move this over here. I've got one black wire hooked up to this bottom pin. Another black wire goes to my voltmeter. Then I've got the red attached to the top part, but it's the only one attached to the top part right now. The red of here is my probe. So I'm going to take this probe and move it around the paper to see what happens. So right now it's not reading anything, but what if I put this probe right where the black thing is? What am I going to read? Well, I'm going to read 0 because there's no voltage. So this is the red. I've got the black lead already attached to there, so I'm shorting the circuit out, which means there's no voltage across it. Now, if you put it all the way to and touch the red part or the positive part, I should read 15 volts. So it's 15.07. This multimeter set on DC volts is actually more precise than my this readout here. So I've got about 15.07 volts attached across, and it's close enough to 15. So now what we're going to do is we're going to go up in increments and measure it. The first thing I want you to do is on your graph paper is draw a picture of what you see on here. So let's count. Here's the bottom one, 1, 2, 3, 4, 5. So draw a straight line, and hopefully you have a ruler. And okay, there's a middle part, but I guess it doesn't matter. Just draw a straight line somewhere underneath it here. And then we're going to count a certain amount above it and redraw it. So let's do that on this piece of paper. So just make sure, if you want to make it neat, you can have a ruler. So I'm just going to pick one of these. Doesn't matter which one. Just go right through. Oh, I drew it too long. You have to draw it a certain length too. So let's go figure out how long we want to draw this. Okay, so let's start from the right and count how many boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12. So let's see, I might have overdrew my line. Let's see. I start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 6, 1, 2, 3, 4, 5, 6 on one end, 1, 2, 3, 4, 5, 6 on the other. So there, that's my line right here. So I'm just going to kind of draw what it looks like. It's like this little silver line. So there. So I've drawn my silver line. And again, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Then what we're going to do is draw another one of these 5 spaces above, or 5 crosses above. So again, let's count again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So at the 5th cross, we're going to draw our next one. So just transfer it over. 1, 2, 3, 4, 5. And just kind of draw it across to where the other one is. And then you have it. Okay, and you're putting your pins here, and you're all set. Now what we're going to do is map out the 3-volt potential, the 6-volt potential, the 9-volt potential, the 12-volt potential. And we're going to draw it on our graph paper.